Hello class, this is Mr. Hart, and on this Livescribe I want to go through the second example problem on the 2.6 slides. And so we just have a simple trajectory of an object going up and then back down and falling off a cliff. And we want to find the maximum height that it reaches and the time it takes to do the full trajectory. Okay, so let's just start with the height first. Okay, now in this case we are just simply looking at this part of the trajectory left of the maximum height. Okay, so what we can do is we can just look at that point. So we're going to just say the change in y equals v naught times the time, okay, plus 1/2 gt squared. Okay, now you'll probably notice there's a problem here, right? We don't know the total time it took for this motion to occur. Okay, so what we're going to need to do is we're going to have to use the fact that we know that the velocity is 0 at the top. If that's the case, at the top of this motion, v naught equals 0. Okay, that's when it's motionless for that short amount of time. So this equation right here really doesn't make any sense. Okay, we want to use this equation first. We're going to say v final equals v naught plus gt. Okay, and sorry, I didn't mean v naught up here, I meant v final. Okay, so v final equals v naught plus gt. Well, we know it's equal to 0 at the top of that motion. Okay, so we say v naught plus gt. We're going to solve for t, see how long it takes to go up, and then we'll plug it into the other equation. Okay, so we're going to minus v naught to the other side and divide by g, so we get minus v naught over g equals t. And in this case, v naught was 4 meters per second, and g was negative 9.8, okay, which will give us time. And if you just put that into your calculator really quick, then you should get that is equal to, sorry, I'm running this on Google search. It's not the most efficient thing in the world. Okay, there we go. Should get that it's equal to 0.41 seconds. Okay, so now that we know that, that's the time to maximum height. So I'll call that T max. Okay, we can plug that now into the change in y equation. So change in y equals v naught T max plus 1/2 gt max squared. And so we just plug in what we know. V naught was 4 meters per second. T max was 0.41 plus 1/2 times, again, make sure you're very picky about the signs. This is negative 9.8 meters per second squared times 0.41 squared. Okay, so we plug that all in. Just give me a second to do this on Google search. So 4 times 0.41 and minus 4.9 times 0.41 squared. And so if I did that right, you should get that the total height that it reaches is, let me just make sure that's right. Yep, so that should give you 0.81 or 0.82 meters actually. Okay, 0.82 meters. So that's the maximum height it reaches. So even though you threw it at 4 meters per second, which is a decent speed, it doesn't go very high. Gravity gets a hold of it pretty quickly. Okay. Alright, so that's the first part. So what does y max equal? Well, it is equal to 0.82 meters. Okay. Now, let's do the other one, t. Okay. Now in this case, we don't have to worry about the fact that it went back up and down. All we need to do is brute force it into the equation that we have. So we're going to say change in y equals v naught t plus 1/2 gt squared. Now keep in mind we're solving for the full motion this time, so we're going to plug in negative 30, right? If we set the cliff as the origin, that's at 0, so it went a total distance of negative 30 by the end, okay? And I'm just going to rewrite this really quick, like this. Now, if you remember how to solve quadratic equations, we're going to put 0 on this side and add the 30 over. I'm going to rewrite this in standard form that you'd see in like your math class. So this will be 1/2 gt squared plus v naught t, and then plus 30. Okay? Alright, so now we're going to have to use the quadratic formula. I prefer to kind of leave things in variables until I get the final result. So I'm going to do that in this case. So I'm just going to plug this into the quadratic formula as is. Okay. So that means that t, if that becomes our x that we would use in the quadratic formula, then we get t equals negative b, which is negative v naught, plus or minus the square root of b squared, or v naught squared, minus 4 times a, which is 1/2 g, times c, which is 30, all over 2a, which is 1/2 g. Alright, now let's plug in some values and see what we get. So minus v naught is negative 4, plus or minus the square root of 4 squared, which is 16, minus 4 times 1/2 g is negative 4.9, times 30, all over what basically becomes g, or negative 9.8. Okay, we're getting close. So I'm going to just rewrite it like this. So negative 4 over negative 9.8 plus or minus the square root of 16 plus, let's just simplify that out right now. So 4 times 4.9 times 30 gives us 588 all over negative 9.8. Okay. At this point the negative doesn't really matter because we have the plus or minus right here. So a couple more steps. 16 plus 588 gives us 604. The square root of that is 24.58. So we get 4 over 9.8 plus or minus 24.58 all over 9.8. Okay. Alright, we're almost there. But what you should realize is we're going to get two different answers here. Okay, one of them will be negative and one of them will be positive. Since we're dealing with times, it doesn't really make any sense to take the negative solution. So I'm just going to cross out this minus right here, because the negative time doesn't really make any sense. If you looked at the trajectory, it'd be as if it was landing right there. Okay, but we don't really care about the solution. It doesn't make any physical sense. Alright, so all we have left to do is 4 over 9.8 plus 24.58 divided by 9.8. And if Google search is working correctly, we should get that the total time for this trajectory is 2.92 seconds. Okay? So there we go. So what's the total time? Well, it's 2.92 seconds. And there we go. So we found the max height. We found the total time it took. Okay? And there you go. Thank you for listening.